for a hydrocarbon. General formula means you can write like this because both numbers of carbons and hydrogens are unknown here. So we can take this in this way. And for a hydrocarbon, there are two unknown, so more observations needed. In the previous case, with one observation, just how much volume fallen, I found 25 is a difference in volume. It should be enough. It could be enough for me. But here we need some more information. Let us see how. Suppose in one question I took, say again, comfortable number, 10 cc of this hydrocarbon I took. And this 10 cc of hydrocarbon I burned with some 100 cc oxygen again. But after burning that with 100 cc oxygen, after the reaction, I found some change in volume. And then I used something like a absorbent like potassium hydroxide. Then I find some other volume difference. So all these will help us to understand what are the numbers of carbons and hydrogen, the values of X and Y. Say, in this experiment, I did like this. I took 100 cc, 10 cc of hydrocarbon gas, and that I burnt with say 100 cc oxygen, and after the reaction is over, I found a mixture, reaction mixture, products present now. What are those? Formed carbon dioxide, water, and also any leftover oxygen gas. Suppose here the measurements I am making at certain conditions where water also in vapor state I will take. So that water vapor also should be taken into account this time. So in that way, when I made the measurements, I found like this. The reaction mixture, I started with 10 cc of this and 100 cc of that. But at the end of the reaction, after reaction, the volume raised. After reaction, the volume raised to 115 cc. Interestingly, here volume increased. And finally, I passed through potassium hydroxide. After passing through potassium hydroxide, the volume decreased. Volume fell to a lesser volume, only 95 cc. The volume fell to 95 cc when passed through potassium hydroxide. And later, I passed through some other absorbent, and finally I noticed that unreacted oxygen left over in the mixture is only, from this I found the volume of the O2 finally left over is equal to some 65 cc. So that tells me how much oxygen reacted in this process. So from these observations also we can complete the calculation. So I am giving the information that in this process leftover oxygen, and here I write, and unreacted oxygen in the process, is some 65 cc. At the end of the reaction I found 65 cc of oxygen left unreacted. So from this information, how do we understand the values of X and Y? Look at this. Because it is a hydrocarbon, here both are unknowns, and now when you see the numbers here, we started with 10 plus 100 cc initially, 10 plus 100 first volume, and second volume after the reaction is 115, and third volume after passing through KOH it is 95, and unreacted oxygen said is equal to 65 cc. This is information we got by observing the volumes. Now, if I write the equation in terms of carbon and hydrogen numbers as X and Y, it is burnt with oxygen, and I get therefore X moles carbon dioxide and Y by 2 moles water. In the vapor state I mentioned, this time measurements made at different conditions where water is not in liquid state, water also in a gaseous state, vapor means gaseous state only. So here the requirement of oxygen, when I again did like in the previous case, I get x plus y by 4. That you can easily understand, because here 2x atoms of oxygen and y by 2 atoms of oxygen, altogether 2x plus y by 2 O atoms or x plus y by 4 O2 molecules. So this is the equation in terms of x and y. I started with 10 cc. So according to this equation, the requirement of oxygen is 10 of x plus y by 4, and formed carbon dioxide 10x, and formed water vapor is 5y. Notice here, I did not ignore this time water, because that is not in liquid state, that also in vapor state. One must consider everything whichever is in gaseous state. So total volume I got. So now the observations are what? When I found the reactions mixer's volume after the reaction, it was found more. 115 is more than this. That means this total volume before the reaction, this total volume after reaction are differing by that 5 cc. So that can give one information for me. And I also have the other information. When I pass through potassium hydroxide, a difference of this 20 cc. So it must be the volume of carbon dioxide. And after that, I found unreacted oxygen 65 cc. Unreacted oxygen 65 cc means reacted oxygen is 35 cc. So here so many observations are there. You can understand how much oxygen reacted, you can understand how much carbon dioxide formed, you also know how much change in volume formed. So any two you can take just to solve two unknowns x and y. I'll take this. Here the difference in volume I found so much. Volume here increased from here to here, and the increase in volume is this difference. Therefore, I can say 10x plus 5y minus 10 plus 10 of the whole thing. Again 10x and 10. So here 5 by 2y. And this difference is equal to this difference. 115 minus 110. That is equal to 5. So in this solvation, I get x cancelled. Therefore, y equal to 6. I get simply y equal to 6. And second observation, when I pass that through potassium hydroxide, a volume fall of 20 cc noticed, which must be equal to carbon dioxide volume. Therefore, now I can say that volume of carbon dioxide, which is according to equation 10x, but I found that equal to 20. This tells therefore x equal to 2. So there I got y equal to 6, here I got x equal to 2. Then the problem is over. C2H6 is the answer. Similarly, we can use any other information also. No doubt, here the other way to handle is, if suppose you don't use this, also it is possible. Because what all we need is to solve x and y two equations. We got x straight away in this observation that carbon dioxide volume decreased by 20. And to get other equation in terms of x or y or x and y, we have so many options. So this is one in which y you got straight away. Otherwise, because he gave another information that 65 cc oxygen left over, started with 100 cc, 65 left over tells what? 35 used up. 35 used up is our observation, but equation says that reacted oxygen must be 10 of x plus y by 4. It means what? That 10 of x plus y by 4 is nothing but equal to 35. And already x is found and y you can calculate. That is one option. And the other way, here I found that to fall 95 after passing through KOH, and I am saying leftover oxygen is 65. That means what? In this 95, what else present? Carbon dioxide already absorbed and unreacted oxygen 65. The difference 30 should be what? Should be the water vapor's volume, because here water also vapor, and that water vapor's volume. And water vapor's volume is y by 2 of 10 or 5y. So 5y is 30. There also you can get y. So all these observations, whichever is available there, can be used to calculate the values here and determine the molecular formula. So this is one very important technique. It is also stoichiometry, but we call it as gas analysis because measurements of volumes of gases is the major observation. Okay, so next time we will see the extension of this and some more stoichiometric principles.